In the past, learning about stargazing involved using star charts as basic tools. In Thailand, we have Thai Astronomical Society's Sky Map, which allows us to rotate and view various constellations according to the desired date and time. With the advancement of technology, especially in the past decade, smartphones and tablets have become powerful tools for learning various subjects. As a result, numerous applications and programs for learning about stargazing have emerged. One of the popular programs used for stargazing is Stellarium. This program allows users to set the position of the sky to observe various celestial objects. It can draw connecting lines between stars, help identify constellations, and display symbols representing different star groups. And from this idea, I want to create a planetarium-like room that mimics the features of the software but in a hardware or semi-hardware format. This room will be an interactive system with sensors capable of displaying the positions of the main stars, constellation lines, constellation symbols, and sound to provide explanations about different star groups. In addition, there is a door that can be opened and closed along the entire wall. I plan to use this specific room in the preclinic building for the project. This room will be different from typical planetarium domes that use software and projectors for image projection.
We call it an interactive universe model display room for astronomical study. When we look up at the sky, we see numerous stars, and one of the largest and closest to us is the moon. Humans in the past divided the stars into groups and created various stories. These imaginative star groups are the constellations that we see when we are on Earth. But what if we change our perspective? What if we stand on the moon and look back at Earth instead? How would these star groups appear to us from there? This is the starting point of the story in this room. Defining the perspective of the sky, when observed from the moon. All the stars we see in the sky are distant from our solar system and Earth. The closest star to us is Proxima Centauri, which is approximately 4.25 light-years away from Earth. When we compare this distance to the distance between the Earth and the Moon, which is approximately 400,000 kilometers, we find that the ratio of these distances is significantly small. This can be compared to standing and looking at the headlights of a car from a distance of 61,528 kilometers, where we would not be able to distinguish the two headlights as separate entities. This means that if we were standing at point 1 on the moon or on Earth on the same day and time and looking in the same direction, we would see the same group of stars. Similarly, if we were standing at point 2 on Earth or on the moon on the same day and time and looking in the same direction, we would also see the same group of stars. Because we are creating an architecture that cannot change, rotate, or move like software on a computer, we must carefully select the most interesting reference points in every direction to use as a guide in constructing this room. The most interesting reference point on the moon would undoubtedly be the landing site of the first human astronaut, Neil Armstrong. This historic location is near Moon's equatorial region and serves as a significant point of interest. Additionally, the proximity of this reference point to the room in Pattani province and near Earth's equator further enhances significance in creating a meaningful connection between the two celestial bodies. As previously mentioned, because this room cannot rotate or simulate time like software, it is essential to select a specific reference day and time for the room. This reference point should be a significant and relevant date associated with science and astronomy. That is a great choice for a reference day. August 18th is indeed a significant date for Thailand, as it is the Thai Science Day. On this day, in the year 2411 of the Buddhist era, approximately 1868 AD, King Chulalongkorn Rama IV of Thailand observed a total solar eclipse in Prachuap Khiri Khan province around noon. This historical event has a remarkable connection to astronomy and science in Thailand, making it a fitting reference point for the room. On that day in August, the constellations Leo and Cancer were visible in the sky. However, since we have changed the perspective from standing on Earth to standing on the Moon at the location of Neil Armstrong's footprints, facing toward Earth, in order to maintain the view of the Leo and Cancer constellations, as seen from Earth on that specific day, we have chosen August 18, 2016, as the reference time for constructing this room. On that day, if we were standing on the Moon and facing north, we would see the Leo constellation on the right and the Cancer constellation on the left. This is the preclinic building that will be used to create the room, and the north direction indicated aligns with the LED screen in the room. Normally, when observing the stars, we stand above the horizon, and the celestial sphere forms a dome overhead. The point directly above us, located at a 90-degree angle with the Earth's surface, is called the zenith. We can only see stars positioned above the horizon line, which we call the overhead constellation. Indeed, 88 constellations are recognized in the entire night sky. If you were to create a room that only displays constellations directly overhead, you would limit the number of constellations visible at any given time. This limitation arises because you cannot rotate the room or show additional constellations as easily as the software can. To address this issue, you might consider incorporating educational materials, interactive displays, or digital tools within the room to provide information about other constellations that may not be visible from the room's fixed perspective. However, we can address this limitation by incorporating a different form of scientific education. This can be achieved by providing a deeper understanding through the following perspective. The Moon, which typically has a radius of 1,737 kilometers and a spherical celestial sphere surrounding it. Observers are positioned along the celestial horizon. 12 zodiac constellations encircling the Moon, creating a 360-degree view. Observers will only see constellations located above the celestial horizon in this context. These constellations include Virgo, Leo, Cancer, Gemini, and Taurus. If we were to imagine the Moon being smaller in size, or if observers were positioned at a higher elevation above the lunar surface, we would have a wider field of view, allowing us to see a greater number of constellations. This altered perspective would enhance the ability to observe multiple groups of stars in the sky. With this adjusted perspective, we would be able to see an additional 4 zodiac constellations: Libra, Scorpio, Aries, and Pisces. This would leave us with 3 zodiac constellations that would remain out of sight: Sagittarius, Capricornus, and Aquarius. In creating this room, I assume that the observer is positioned at the junction between the curved ceiling and the straight wall of the room, which represents the position of the celestial horizon. Below is the simulated lunar surface. When we reduce the size of the Moon, we will also see the constellation underfoot, which was initially hidden by the lunar surface. Here is the model of the interactive universe model display room for astronomical study that we created. It comprises 3 stairs for maintenance, the Moon floor, Neil Armstrong footprint, the large LED screen, 3D hologram fan, 6D for constellations with 2 types of sensors, and a general star. Addition, with entrance and exit doors and a counter system. Here are all constellations that have been created and installed for display in this star room in a flat format. The red line represents the ecliptic path through which the 12 zodiac constellations pass. The gray circle represents constellation that can be rotated and displayed on the large LED screen, totaling 7 groups. It took up to 4 years to build the SAT Astro with the involvement of students in learning and training. This is the room in the pre-clinic building before construction. It starts with building the curved ceiling and the walls of the room. Creating the lunar surface on the floor of the room was the task of the external contractor we hired. Let's build Interactive Universe Model Display Room for Astronomical Study, or nickname Star Room. In the construction of this star room, we began by drilling through the walls to install large LED screens. These 2 students came in to learn and assist with the work. Because we need to replicate the constellation in the sky inside the room, we will have to reduce the size of the constellation to a scale that is suitable for the room's size. Therefore, I had to calculate the size of the areas for each star group that would be simulated in the room. By comparing this as a percentage of the sky and the room's walls and ceiling, and map the constellation in the room using mathematical calculations with coordinate transformation, and test the installation of different constellation sizes within the room. This is the constellation board that fits into the room. Next, we begin by designing and testing the star board. This process requires knowledge of electrical, electronics, embedded systems, and programming. Continuing with the use of artistic knowledge to draw constellation images. But it is not just a regular drawing. It is an engraving of an image on an acrylic sheet. During this process, we also had art students join us to assist in this work. In the process of creating constellation display boards, we can teach students computer-aided optimization techniques, such as genetic algorithms, to find the most suitable solutions, such as the shortest path for routing electrical wires. They also involve students studying electronics, programming, and microcontrollers. These students contributed their knowledge and skills to their friends throughout a period of more than 4 years until the first group of students graduated. Then, the next step is the installation of the star display board. We also have many students joining in learning and practicing. In the control equipment section, I have designed 2 types of control boards. The bottom one uses the principle of an infrared proximity sensor, whereas the top one utilizes a laser sensor as a signal receiver. The operational principles of these boards are also used for teaching students in the class, and they can apply these principles to create their own product, following the STEAM through work piece-based learning technique, which I use to teach the students in the class. In addition, I have added an additional wireless control system with Internet of Things, using the Blink application to control it via Raspberry Pi server, which is connected to a LAN board controlled by a Node MCU. This setup allows us to control the microcontrollers that control each star board. This is the installation controller diagram. The layout of the installation positions for the control boards mounted on the walls and ceiling of the room is depicted in the images. The images show the process of installing the control boards. That's wonderful. It's great to see that many female students have actively participated and learned during this project. In the case of the room's door, since I designed the room to have both open walls and a door that can be open and closed, when needed to limit the number of viewers, there will be a system in place to count the number of visitors in the room each day, as well as the number of visitors who are still inside the room. The state machine diagram of the system can be illustrated as shown in the diagram, and assigned it as a project for a student who came to help with this system. From start to finish, The knowledge used to create this room spans various fields. It goes beyond just using STEM teaching methods, but has evolved into STEAM teaching methods, which I call STEAM learning model through workpiece-based learning.
And here is an example of a time-lapse video of some behind-the-scenes footage in creating the Interactive Universe Model Display Room for Astronomical Study. You can watch the full behind-the-scenes time-lapse video from the link at the end of video. In addition to providing knowledge and skills to the students who participated in the work, the Interactive Universe Model Display Room can also be used for knowledge training and entertainment for visitors from all groups. Since its official opening for about 4 months, more than 2,000 people have shown interest in visiting. This number does not include those who visited during the 4 years of construction, which amounted to more than 5,000 people. After officially opening it for public viewing, we had the honor of welcoming Her Royal Highness Princess Maha Chakri Sarindhern. And there were visitors from various places, including professors and lecturers from universities and teachers from different schools, who were involved in the Thailand Astronomy Olympiad academic competition. Students from various schools in the area also visited. Students from different faculties at the university also attended. Preschool students from various schools also visited.
โดยห้องนี้ก็มีนักศึกษาช่วยทำหลายของมันโดยที่ผมสอนเทคนิคในรูปแบบและโปรแกรมด้วยแล้วผมยังว่านักศึกษาได้มาเรียนรู้ของจริงด้วยก็ได้เรียนที่ด้วยครับนี่ก็ทำผมได้ครับ
This is the unique Interactive Universe Model Display Room for Astronomical Study, which is the only room in the world at this time.
จากความรู้และทักษะที่กล่าวมาทั้งหมดเมื่อสักครู่นี้จึงเกิดมาเป็นห้องแสดงจักรวาลจำลองเพื่อการเรียนรู้ทางด้านดาราศาสตร์แบบโต้ตอบได้ห้องนี้สวัสดีครับ